Hello, this is Calculus Lesson 2. We continue the last Lesson 1. We talked about even functions and odd functions. Let's have some examples. More examples on even and odd. Example 1. I have a function of x is equal to x sine x plus cosine x. First, we want to ask, is sine x even or odd? And is cosine x even or odd? To answer that, we just look at the graph of sine x. This is the graph of sine x. And you look at the graph, you see sine x is an odd function. Because the graph is symmetrical with respect to the origin. If you reflect this part in y-axis, you get this thing. And then you reflect in the x-axis, and you get this part. So you do two reflections, and you get the whole sine graph. So it's an odd function. Next, you will ask whether cosine x is even or odd. Again, we draw a graph. This is the graph of cosine function. And you see that it is symmetrical in y-axis. Therefore, cosine x is even. Mathematically, to find out whether it is even or odd, we replace x by negative x. So we do that. So we replace x by negative x. So this becomes negative x. And here becomes negative x. And here is negative x. Negative x is an odd function. What I mean is x is an odd function. We already see that sine function is odd. And cosine from this graph, we see it is even. So here, it's odd times odd, it's even. Odd times odd becomes even. And this is already even. So even plus even is even. So that is, from the graph, you can tell that. And then mathematically, you have a negative here. Since sine function is odd, so you get a negative from here. So negative, negative is positive, you see. So this is identical to the original function, and this is identical to the original function. So replace x by negative x does not change the function. It is still the original function. That is exactly the definition of even function. Next, example 2. Example 2, function of x is x cosine x minus x cubed. We have already seen that x is an odd function. Cosine x is an even function. And this is an odd function. It is simply that you look at the power here. This is 3. 3 is odd. Therefore, the function is odd. So I have odd times even. Odd times even is odd. And this part is odd. So odd and odd becomes odd. Mathematically, if you replace x by negative x, you get the negative of the original function. So which means it is odd. Next example. Function of x is equal to 2 to the exponent x minus 2 to the exponent negative x. Now in this case, you can also draw a graph, but it is more complicated than the first example and the second example. So what we do is just do mathematically. Replace x by negative x. Replace x by negative x here. So this x becomes negative x. This x becomes negative x. But notice that there is already a negative. So it's negative, negative x. Negative, negative x is positive x. So this is the result after we replace x by negative x. But look at this. I can rewrite this, put this as a first term, put this as a second term, and then I have this. I get a negative sign before the bracket. The bracket is exactly the given function. So the result is the negative of the given function. Replacing x by negative x, the result is the negative of the original function. So it is odd. Next example. Next example, f of x is x squared minus 2x plus 3. This you can draw a graph because it's a quadratic function. To draw a graph of a quadratic function, you can have two methods. One is factoring. If you factor, you get 2x intercepts because this is a quadratic function. So you get 2x intercepts, and then you can have a sketch of the parabola. Quadratic function means a parabola. Or you do completing the square. If you do that, you get the coordinates of the vertex. And from the square term, whether it is positive or negative, you know the parabola opens up or opens down. So you can do that from the graph. You can tell whether it's even or odd. But now here, we just do mathematically replace x by negative x. Then x here becomes negative x. This x here becomes negative x. Negative x squared, it is still x squared, but here you get a negative sign, and you have two negative signs. Negative, negative, it becomes positive. You compare this function with the original function, they are not the same. And they are not even the negative of the original function. So the result is replacing x by negative x, it's not the original function. Replace x by negative x, it is not the negative of the original function. So it is not even, it is not odd. So next, we want to investigate whether a function is an increasing function or a decreasing function. Let's have an example. Example 1 is a log function. Now, I advise you to know the shape of a log function. You can get the shape if you do a table of values. So if you do that, the log function, the general shape is this. The log function, the graph is only for x is larger than 0. X cannot equal to 0. When x is 0, the function is undefined. Yeah, it goes to negative infinity. Yeah. So this is a graph of a log function. So the log function requires this part, which is x. The x has to be positive. So this, from the shape of the graph, you know that it is an increasing function. I must remind you that if you want to decide whether it is increasing or decreasing, you trace the graph. So you can use a pencil to trace the graph. But you always trace from the left-hand side to the right-hand side. You never trace like this. No, you trace like this, from the left side to the right-hand side. Trace like that. So you see that it is increasing. The next example, f of x is 1 minus x squared. This function is a quadratic function. So it is, the graph is a parabola. So the parabola is x squared, and it's negative x squared. So the parabola opens down. But the origin, the vertex of the parabola is not at the origin, because there is a translation. 1 means you move the parabola up. Move the parabola up by 1 unit. So this is the graph. Once you have the graph, you can answer the question increasing or decreasing. And from the graph, you see that this part is increasing. As I have mentioned in example 1, when you trace from the left to the right. So you trace from here to the right. So it's increasing here. And continue the tracing, you have this. So it is decreasing. So for this function, it is both increasing and decreasing. So next, we need to do some practice. Let's do some practice exercise. I have question 1. Question 1 is to find out the domain of the given function. I have 3 functions, A, B, C. What is the domain of this function? What is the domain of this function? What is the domain of this function? So this is a practice. Please try your best to answer this. So question 2 is, to ask the given functions below, are they even functions or odd functions? Each one, A, B, C, D, E. Is A an even function or odd function? Is B an even function or odd function? Is C an even function or odd function? Is D an even or odd? Is E an even or odd? So, do your best to answer these questions. I have answers for that. So here are the answers. So the answers are here. You can copy the answers down or just look at the answers. You check the answers after you finish the exercise. Okay, this second lesson, this is all I have for lesson 2. Very good. So I'll see you the next lesson then. Goodbye. Thank you for watching.